Good morning, students. Is my voice audible?
Yes, sir. Good morning.
Right. Students, till now we have completed 5 experiments in our laboratory sessions. Today we are going to complete 2 experiments, that is 6th one and 7th one. Before going to our experiments, we will discuss a few topics. Students, this device is called LVDT. This experiment we have completed in last week session. But point is here we are using inductors, primary coil and 2 secondary coils. So in LVDT we are using inductors. And this device is called as synchros and this device is called as resolver. We have discussed all these topics in theoretical classes, but here why I am showing these devices construction again. So here in these devices, we are using coils. That is, we are using inductors. And not only in synchros and resolvers, the last topic, the moving coil device. So here also we are using coils, that is inductors. So in many sensors, we are using inductors. In many sensors, we are using inductors. Depending on the variation of the inductance, we will estimate the physical parameters. So importance of measuring inductance is very, very important. So today our experiment is measurement of self-inductance by Maxwell's bridge. So we use an inductor in the circuit and we will estimate its inductance. That means inductance is unknown. So I will forward link in the chat box, website link. All of you open this website. Our aim is measurement of self-inductance by Maxwell. Measurement of self-inductance means inductance value we don't know. So inductance is unknown. So aim of the experiment is measuring unknown inductance by using the Maxwell's bridge. And here we have Maxwell bridge. And 4th experiment is our Wheatstone bridge. So here we have same type of bridge, but here not only resistors we are using capacitors and inductors. So this is our unknown inductor L. And we are using resistors in these 2 arms. And here we are using variable capacitor and variable resistor. R4 is fixed resistor and R2, R3, R1 are variable resistors. And equation for the measurement of unknown resistance is this one. L is equal to R2, R3, C1. You go through the theory for 5 minutes, then now we will discuss about the circuit. So all of you open this website and go through the theory and be ready to share your screens. Randomly I will call roll numbers from different sections. Everybody has to share, everybody be ready to share your screens. Depending on your responses, you will get marks at the semester. The students, here we are using Maxwell's bridge, and this is unknown inductor, and MV is our voltmeter. This voltmeter can measure only millivolts, and we are using 4 arms. Unknown inductor is connected in 4th arm. At 2 corners, we have to supply input, so we are using AC supply, that is BS here, and we are collecting output from the remaining 2 arms, and we are measuring voltage. When impedance is synonym of resistance. Resistance term we use in DC applications, and impedance we use in AC applications. When the 4 ohms impedance or resistances are equal, bridge will be in balanced condition. When 4 ohms impedances are equal, bridge will be in balanced condition. When bridge is in balanced condition, we won't get any voltage at the voltmeter. Okay, we won't get any current flow at the voltmeter. So we will get 0 reading at on the voltmeter. So this is the theory of the Maxwell's bridge. Maxwell's bridge is exclusively designed to measure the unknown inductance, and we are using 4 resistors, 1 capacitor, 1 voltmeter, and AC supply in this bridge. When bridge is in balanced condition, we won't get any reading on the voltmeter. So what is the meaning of balanced condition? When 4 ohms impedances are equal, bridge will be in balanced condition. And all the component values we know except this inductance. So when bridge is in balanced condition, we can easily estimate the unknown inductance because 4 ohms impedances are equal. So that is the logic in the Maxwell's bridge. So after completion of theory, go to the procedure. All of you click on the procedure. You will be directed to procedure page, and here we have procedure, and procedure we will get on the simulation page also. So you can go to the simulator. So again, you have to click on the link for the simulation page. You will be directed to the simulation page, and here we have procedure, and here we have circuit. Follow the procedure and find out the unknown inductance value, and this is the switch. When you press the switch, circuit will be in active condition. The active condition means input is applying on the circuit, so you will get some reading. So here, what is your task? By changing the resistors and by changing the capacitor, you should get reading at 0. If you switch off, immediately showing 0. After switching on also, you have to get same type of reading on the voltmeter. That is your task. So here we have the procedures, different steps. Follow the steps and find out the unknown inductance. And students, we are assuming inductance is unknown, but here we know the inductance value, that is 0.05. So after pressing the measure inductor value, you should get same value as appearing here, 0.045. Okay, so you have the circuit and you know the procedure. We have completed 5 experiments. Try to get the 0 reading on the voltmeter. I am giving you 10 minutes time. After 10 minutes, I will call roll numbers. You have to share your screens and you have to show your outputs. Okay, right. CSC 145.
Yes, sir.
Share your screen.
Yes. Sir, disabled.
Yeah, 1 minute. Can try now.
Yes, 1 second. Yes, sir. Sir.
Okay. But you're supposed to get 0.
I'm doing it, sir. Like just now I got it 0.04.
Good.
I'm doing it.
Good. Change the component values, you will get nearly 0. Okay.
Yes, sir.
Students
I think this is the only nearest value we could get. So I'm
No.
Okay.
Students, listen, all of you. You won't get exactly 0. You will get 0 point at least 002 or 001. 0.0. At least 3 zeros you should get. Okay. This is 0.04. Good for this, but try to get some more small value.
Yes, sir. Sure,
more
sir.
near to the 0. Okay.
Yes, sir.
Okay, right.
Thanks.
Students, I am giving you another 5 minutes. Try for the 0 value. CSC 146. Share your screen. CSC 146. CSC 146. I am giving you 2 minutes time. Within 2 minutes, we have to give response through mic or through chat box. Otherwise, I will remove you from the session. Okay. CSC 330. CSC 330. Yeah, 46. Whether you complete or not, you have to share your screen. Yeah, I'm giving you 5 minutes time. 46 CSC 1. Within 5 minutes, you have to share yours. Yes, CSC 330. CSC 330. CSC 350.
Yes, sir. Can you hear my voice, sir? Hello.
Yeah, 15. I said 50.
Oh, okay, sir.
CSC 315. Sorry, CSC 350. 50. CSC 330 and 50, I am giving you 2 minutes time. Otherwise, I will remove you from the session. You have to give response. You have to share your screens. CSC 58. CSC
Yes,
5.
sir.
Share your screen. Have you got value?
Yes, sir. 0.0 near.
Yeah. Yeah. Roll number 8. Wait for 1 minute. The CSC 330. You have to share your screen. Okay. I accept that your mic is not working. But after roll number 8 sharing, you have to share screen. Be ready for that. Yeah. CSC 58. Click on the measure inductor value. Here, left side you have, below the procedure you have. Measure inductor value, right?
Yes, sir.
Simulate, click on simulate. So what is the inductor value you got?
0.00 sir.
Move your cursor near the inductor on the circuit. What is the inductor value there? LX.
0.045, sir.
So here you should get at least 0.044 or 0.043 because you are using 0.045 inductor. So why you are not getting? Because your voltmeter reading is not 0, that is 0.01. Try to get at least 3 zeros after the decimal point. Okay, 8?
Okay, sir.
Yeah. Stop your sharing. Yes, CSC 330, share your screen. CSC 330. Yeah, CSC 3 students informed to roll number 50 that I am removing him from the session. Yes. Yes, Sharon, you can share your screen.
Sir,
Yes.
sir, I got 0.00873.
Yeah, no need to show your voltmeter reading. You can verify with the measure inductor value. Okay.
Okay, sir.
See here, inductor value is 0.053.
Yes, sir.
Little bit more than the inductor which you are using. So what
Yes,
you have
sir.
to understand again, you have to decrease the voltmeter reading
Okay, sir.
by varying the different values. But you got nearly exact
Close.
value of 0.045. Very good for that. Sure.
Okay, sir. Thank you, sir.
Yes, 59, you can share your screen.
Are you able to see now, sir?
Right, very good, very good. Your output is correct. Very good, your inductor value is correct. Yeah, share your screen for 2-3 minutes. Your friends can read, note down component values. Okay.
Okay, sir.
Students, all of you use these component values and try for the output. Yes, Vidya, you can stop sharing.
Yes.
CSC 9, roll number 6.
Sorry, yes, sir.
Explain about experiment. Yeah, click on the measure inductor value, Babu. Your name is, what is your name?
Shashank.
Yes?
Shashank, sir.
Shashank, click on the, right. Click on the simulate. Right. Right. Explain the experiment.
Like it's Maxwell Bridgestone experiment.
Go to theory page and read out the theory.
In this bridge, an inductance is measured by comparison with a standard variable capacitance, as the connection shown.
What did you understand? Shashank,
Sir,
what did you understand about the experiment?
we measure an inductance. We'll measure the
Inductance.
inductance
Right. By using
resist.
variable resistors and capacitors. Okay.
Oh,
What is the name of the bridge?
Maxwell's bridge.
How many arms you have? 4 arms.
4.
Okay.
Okay.
Where is R2?
Yes.
That is second arm. Where is R1?
Yes.
First arm. Where is R3?
Yeah.
Third arm. Where is R4?
Yes.
Where is our inductor? In which arm we have unknown inductance? Unknown inductance.
4.
Very good. Which meter we are using? Voltmeter or ammeter?
Voltmeter.
Which type of input we are using? AC or DC?
DC.
Which type of input we are using? AC or DC?
DC, sir.
DC. No, AC.
Yes.
Okay.
Okay, sir.
So you can see symbol here. Move your cursor near the VS. VS input VS Shashank. Below the bridge we have input VS. Okay. Whenever we are seeing that symbol, that is AC signal.
Yes.
Okay. Which type of symbol? Circle with that waveform.
Oh.
Okay. So which type of input we are using?
AC.
AC. And what is the voltmeter reading in balanced condition? Go to the previous page, simulation page.
0.04. 004.
Yeah, we are assuming that is 0.
0.
The value is very small, so we are assuming that is 0. So in balanced condition, bridge output will be 0. Okay.
0. Okay, sir.
And what is the formula to find out the unknown inductance? Formula. Again, go to theory page. Tell me the formula. Below the circuit, we have formula. Below the phasor diagram. Okay. Okay. Scroll up. Students, where do we have seen formula, right? In which page we have seen formula? Scroll down session little bit. L is equal to R1, R2, equation 1 and equation 2. Yeah, here we have Shashank.
Sir.
Above the phase diagram, phase diagram. Yeah, refresh the page, Mr. Shashank.
Okay.
Right.
L is
L is
equal
equal to
to
R2, R3.
R2, R3, C1.
C1. That is the formula to find out the unknown inductance. Okay, Shashank?
Okay, sir.
Right, Amma. Yes, CSC 330, you can share your screen. Simulation page. Every week you should be ready to share your screen. Okay. Stop sharing.
Sir, once can I share?
Yes, 27 you can share.
Can you see, sir?
Yes, explain the experiment.
Sir, here I got the value of 0.045.
Very good, Babu.
Yes, sir.
Exact value you got. And what
I
is the
replaced the
output?
value of RK
Okay.
by 40.6.
Instead of 0.0004, you got 0.0001. Very good.
Yes, sir.
Yeah.
When I
Explain
simulated, I got 0.04.
Yes. Students, these values are some more accurate. Follow these values. And previous one is also correct. Okay, you have to upload different types of images anyway. So upload this image and that image also. Yes, 27, explain the experiment.
Sir, in this experiment, we are calculating self-inductance by using a Maxwell bridge, which consists of 4 resistors and 1 inductor, which is an unknown one, and also a capacitor. By changing these values, we can find that unknown inductance, sir. When the bridge is in balanced state, the voltmeter will show the 0 reading, sir.
Very good, 27. Right, stop sharing.
Thank you.
Students, I am giving 5 minutes time. Try with different values, then we will go to the next experiment. Students, our seventh experiment is measurement of capacitance by sharing bridge. In previous experiment, we have measured unknown inductance, and this bridge is for unknown capacitance. This bridge is for unknown capacitance. C1 is the unknown capacitance. Name of the bridge is sharing bridge. And the purpose of this bridge is to measure the unknown capacitance. Okay. Same type of, yes, 46, I will inform you about the images, how many images we have to upload after completion of this experiment. Okay. Right, students. So as we have completed Maxwell's bridge, here you have theory and here you have simulator page. Bridge is different, that is Maxwell's bridge and this is sharing bridge. In Maxwell's bridge, we are measuring unknown inductance. In sharing bridge, we are measuring unknown capacitance. Remaining theory is same. Here we have 4 arms and C1 is the unknown capacitance. We are not using any inductor in this circuit. When bridge is in balanced condition, we will get 0 output at the voltmeter and we are using AC supply. By varying the different component values, we can estimate the unknown capacitance. Formula for unknown capacitance is R4 into C2 divided by R3. That is R4 C2 divided by R3. This is R4 and this is C2. And here we have R3. Okay. So I am giving you 3 minutes time. I will post this website address in the chat box. Open that website, everybody. Hi. CSE 11, Sharon, have you shared your screen today? CSE 1153, Sharon.
Yes, sir. I shared my screen, sir.
Okay, Raman, right.
I showed you also, sir. Yes.
Yes, yes. 57. CSE 1157.
Yes, sir.
Share your screen.
Sir, are you able to see?
1 minute. Okay, right. So, can you explain sharing bridge experiment?
Sir, actually, it is used to measure the unknown capacitance.
Okay, good. Which
We
type
have to
of
supply, sir,
input you are using?
AC.
Okay. Only 2 points you have given about the sharing bridge student. Explain the procedure.
So we have to put different values for the capacitance to find the unknown capacitance of the capacitor C1.
Okay. Switch on the circuit. So you should get a 0 value as output in voltmeter. Okay.
Yes, sir.
Yeah,
Okay,
stop.
thank you.
Sir, here also in sharing bridge, we need to get approximately 0 in voltmeter.
I didn't understand your voice. Can you repeat?
I mean, now we are doing sharing bridge, no, sir.
Yes.
In that also, we should get approximately 0 value in the
Yes,
voltmeter.
correct, correct.
Once can I share, sir?
Yeah, share.
I got this much value, sir.
Yeah, simulate. Yes, you got exactly capacitor value. 0.01 microfarads we are using. In the reading also you got same. Very good.
Yes, sir.
Keep your screen sharing for 2 minutes. Your friends will follow the same values. Students, all of you follow these values.
The capacitor C1, we need to get it as 0.01 like that, sir.
Because that is a fixed value. Because we are using same value
Okay, sir.
before giving the power supply.
Yes, sir.
Your CSC 327, right?
Yes, sir.
Yes, sir. Stop sharing the 27. CS 1159. CS 1159. I'm giving you 2 minutes time to share your screen. Yes, triple E students are on session lo. Triple E. Vamshi, are you there? Triple E students. Triple E students, if you are in this session, switch on your mics. Yes, Snehit. Snehit, switch on your mic. And Dheeraj, Triply Dheeraj. Triply Dheeraj and Snehit. You have to give response, otherwise you will lose marks. Dheeraj and Snehit. Yes, students, voluntarily, if you want to share, you can share your screens. Yes, you can share
Sir,
23.
again, do I need to share or is it?
Yes, 27.
Again, do I need to share or is it enough, sir?
Enough, enough.
Okay, sir.
Yeah, 23. Yeah, you can check your output with the capacitor value here. 10 microfarads you are getting, which is wrong because you are using 0.01 microfarads. Okay, where is the component values? Then you will get nearly 0.01 capacitor value after clicking the simulate button.
Okay, sir.
Right.
So 37, can I share? 7th
1
batch.
minute, Amma. 1 minute, I will give permission. Yes, which section? The 37?
7th batch, sir.
7th section.
Yes, sir.
Right. Yeah, you can share.
So second.
Okay. Correct, but try to get some more smallest value. Okay.
Okay, sir.
At a voltmeter. Right.
Yes.
Students, if you want to share voluntarily, you can share.
Sir, can I share?
Yes, 44 you can share. You are from CSC 5.
Yes, sir. CIC 5.
Okay. Another student requested permission.
Okay, sir.
Wait. 44 you can share your screen. CSC 5 44.
Yes, sir.
I explain experiment.
Sir, this experiment is actually for measurement of capacitance by
Measurement of unknown capacitance.
measurement of unknown capacitance by scaling bridge, sir. It consists of 3 capacitors, R1, R3, and R4. Sorry, 3 resistors, R1, R4, and 3 capacitors, C1, C2, and C3. So we give the capacitance values of C2 and C4 and C1, and we'll give the values of resistance R3 and R4. We'll find the unknown resistance by simulating.
Okay, Amma. Good.
Whenever we get the value as 0, then it is equal or it is balanced.
Okay, Amma. Very good. Is another student requested? If you want to share your screens, you can share.
Sir,
Yeah, share your screen.
sir?
27.
Yes, sir.
Yeah, explain experiment. But okay, right. Correct. So okay, good.
Sir, C is the changing, we should find the C1, sir. and see here 3 capacitors and 3 resistors are given. By using those we should find the C1, and here C2 and C4 should be equal, and by change R3 by change R3 is the steady capacitance. By changing R4 is the variable resistance. By changing R4 we can calculate the value of C1, sir.
You said some two values are same. Which value should be same?
These are C2 and C4, sir. They are
Do we have that type of condition?
no, sir, but I have took, sir.
Yeah, you have taken such type of values. Okay. But there is no, we don't have that type of condition.
Yes, sir.
Okay, Machandana, right. So students, no need to ask permission in the chat box, directly you can share, because I am listening another student's answer, so I cannot focus on the chat box. Directly you can share one by one.
Sir, can you see my screen?
May I know your number?
23 from CS3, sir.
Already roll number 60 is sharing from some section. After that you can share. Yes, 60, you are from which section? 11 or 1?
11.
Okay, right.
Can you see, sir?
Yes, explain the experiment.
Sir, in this experiment, we are finding the unknown capacitance value by varying other capacitor values and resistor values and obtaining null value in the voltage.
Okay, ma, good. Next.
Sir, can you see now?
Wait. Right, 23.
Yes, sir.
But you got very large value as output near the voltmeter.
Wait a minute, sir. I did a mistake again.
Yeah, students, for these two experiments, we have to upload at least five images. So after this lab session, I will create links to upload the images. But some of the students are not uploading images. After the final date, if you submit, you will lose marks. So very easy to upload. Why you are not uploading? I am not understanding. So for Maxwell's grids, you have to upload 5 images, and 2 images should be with nearly component value. So in Maxwell grids, we are finding out the inductance value. So we are using 0.045 Henry's inductor in the circuit. So at least you have to get 0.044 or 0.046 nearly equal value for 2 images, and remaining 3 images should be wrong values also fine, because we are doing experiment to find out the unknown inductance. So wrong values also okay to upload, but at least 2 images you should get exact value. For sharing grid also same, upload 5 images and 2 images should be with the exact value, very similar values of the component. In sharing grids we are using the capacitor. So capacitor capacitance we are using as 0.01 microfarads. 2 images should be equal to that 0.01 microfarads, and the remaining 3 images should be random values. Okay, no problem. Next. If anybody wants to share your screens, you can share. I will note down your responses. It will be helpful to increase your marks. Right, you are from CSC 5. Explain the sharing bridge experiment.
Sharing bridge experiment is used to measure the unknown capacitance. We'll change the capacitance and resistors values to obtain the value, null value in the output, sir.
Which type of input you are using? Which type of input you are using? 13.
Sir?
Which type of input you are using? AC input you are using. Okay.
AC, yeah.
And what is the meaning of balanced condition of bridge?
when we get the voltage 0, the bridge is in the balanced state.
That is the indication. Getting 0 output on the voltmeter is indication, but the balanced condition meaning is how many arms we are using in the bridge, how many arms we are using in this bridge. 4 arms. So if 4 arms impedance or 4 arms resistances are equal, then bridge will be in balanced condition. So when bridge is in balanced condition, voltmeter will show 0 reading. That is the meaning. Okay. 4 arms resistances should be equal. Okay. Right. Yeah. Stop sharing. Students, share. Yes. Very good. CSC 1144.
Yes, sir. Sir?
Yes. Explain your experiment.
The main aim of the experiment is to find the unknown capacitance, and this has 3 capacitors and 3 resistors, and the input used here is a AC alternating current, and by putting different capacitors and different capacitance value, we get the unknown capacitance value, and by changing the values, we get the voltage as a null. If you get the voltage as a null, then the bridge is in the balance. If the 4 arm resistance are equal, so that the bridge is in voltage.
Okay, all right.
Sir, can I share my screen?
Yes.
So can you see my screen?
Yes. Explain your experiment.
So we have to find the unknown capacitance value by changing C2 and C4, R3 and R3 and R4. If we change those values, we'll get the null capacitance value, null value, and that indicates that the bridge is balanced condition.
Okay. What is the formula to find out the unknown capacitance?
Sir.
Yes. Yes, student.
Yes, sir.
17.
Yes,
what
sir.
What is the formula to find out the unknown capacitance? C1 is equal to?
C1 is equals to R4 into C2 by C3.
Okay, all right. Stop sharing.
So we have the Maxwell bridge. The Maxwell bridge is basically consists of 4 arms with 4 impedances because we have a...
1 minute, 1 minute. Have you completed sharing this?
Yes, sir.
Okay, then continue.
So we have 4 impedances because we have an AC voltage input. So basically, if the impedances are balanced, which means that they're equal, the voltmeter should have a no reading, which is 0. So the shading bridge is also similar to the Maxwell bridge, but here we have to find the unknown capacitance where we change the values of C2, C4, R3, and R4, and basically C1 is equal to R4 into C2 by R3.
Okay.
Sir, is the values right now?
Let's explain Maxwell's sharing bridge.
Sir, in this bridge, we are trying to know the unknown inductance of this by changing the values of C1, R1, R2, and R3. And if the null is achieved when we are simulating this, then we get the inductance value by this Maxwell bridge. Sir.
Okay, ma.
So can you see my screen?
Yes.
So should I explain the experiment now? So basically, this is the experiment which determines the capacitance of the unknown capacitor.
Okay.
Where the values are C1 equal to unknown capacitance, C2 equal to standard capacitance, and C4 equal to variable capacitance.
Okay, ma. Right. What is your number?
So 4CS9.
Okay. Right. Students, voluntarily, if you want to share, you can share.
So can I share my screen?
Yes.
This is the experiment for scaling bridge. Here in which the one of the capacitance is unknown and then the rest three are known. So we are setting the values for the other capacitance and resistors in such a way that we achieve the balance condition. We achieve this balance condition when the impedance is equal, and then we get approximately 0 in the volts, and the capacitance should be equal to 0.1 farads.
Okay, ma. Students, yeah, 1 minute 32. Yeah, students, when can I conduct lab examination? Next week or after that week? Next week, Wednesday is.
Sir, I think we have meets.
Okay. On which date?
I think from next week, sir. I mean Monday.
13th onwards.
Yes, sir.
Okay, then on 22nd, we can conduct lab examination. Is it okay, students?
Yes, sir.
So I will conduct 2 lab examinations. So first lab examination will be on 22nd September. Okay. So be prepared with the topics. Yes, 32.
Can you see the screens?
Yes. Explain your experiment.
Sir, in this experiment, we should find the value of unknown capacitor. For that, we have to change the values for C2, C4, R4, and R3. So, and with the formula, C1 equals to R4 by C4 into R3, we'll get the unknown capacitance value. Sir.
Okay, good.
Sir, only 7 experiments, sir, in this course.
Pardon?
Only 7 experiments are there, sir. Total.
No. After first lab examination, another 3 experiments we will do.
Oh, okay.
After completion of those 3 experiments, the second exam I will conduct.
Okay, thank you.
Okay, but I supposed to conduct after 5 experiments, but you have mid examinations, and because of many reasons, I have completed 7 experiments. Today you supposed to write examination, but time didn't allow, so I'm conducting on 22nd September. Okay.
So the exam will consist of first 5 experiments or the 7 experiments?
7.
7 experiments. Okay, sir. Thank you.
Yes, 49.
So we are like here we are going to measure C1, the unknown resistance. We have 3 capacitors and 3 resistors. By changing the value of these, we can find the voltage. If the 4 arms impedance will
is like 0, the bridge will be, this will be balanced, and the output voltage will be 0. And
explain once again.
Okay, sir. So we are measuring the unknown capacitor C1, which is C1 here. So we have 3 capacitors, 3 resistors. C1 is like R4 into C2 by R3. If the 4 impedance arms of 4 impedance are equal, then the bridge is balanced, which means the voltage is 0. I mean, nearly equal to 0 here.
Right, which is unknown capacitance?
C1, sir.
Okay. So, what is your name?
Preeti, sir.
Preeti. So, how much frequency you are using?
500.
Change it to 50.
Okay. Sir.
Did you observe output? Output voltmeter output.
Yes, 0.
Increased or decreased? For 550. Now you remember for 50. Now again you change the frequency and observe.
Okay, sir.
Switch off the cell. Switch off for power supply. Is it same value or different value?
Same, sir.
Change it to 10 frequency.
Okay.
Switch off.
It decreased, sir.
Simulate.
Yes.
Increased or decreased output voltmeter output.
Decreased, sir.
Again change it to 2, 10 to 2. Power off change. Yes. Now?
Decreased again.
So what did you understand?
This is directly proportional to frequency.
No, if frequency decreased,
This is also decreasing.
Voltmeter reading is decreasing. So that if you use less frequency AC signal as input, it is easy to get capacitance calculation because it is easy to get 0 reading on the voltmeter. Okay?
Yes, sir.
Right. Stop sharing. Students, I have created links to upload images. If you want to upload, you can upload. And within 5 minutes, I will wind up the lab session.
Be online only. Be online only. Be here only until the class ends. Ma'am? Yes, ma'am. I send you, ma'am. Here it is not there. FA1. FA1 answer script. One step. I didn't get. Ma'am.
Or can we leave?